This is Honors Algebra 2 Pre-Calc. We're doing section 6.4 of Pre-Calc, but we have entered physics land. So what we're doing now is we're doing a problem that uses that projection formula, the projection of u onto v, which again is something you're going to encounter really in a physics class and not honestly in my class in particular, but it's worth you seeing it so that when you see it in physics you don't have a panic attack. You don't have to have the projection formula memorized. You can definitely look it up. It's on page 444 of your textbook. So again, this formula that we're going to need is going to be on page 444, and it's totally fine to have to look it up either on the in the textbook or on the interwebs. All right. So we're given this u, which is 3, negative 4, so this is my u vector, and we're given v, which is 5, 1, so that's right there. And we're asked to write u as the sum of two orthogonal vectors, one of which is the projection of u onto v, right? So this u1, so what we're saying here is we're saying that here's my u. I want to write u as the sum of this red vector, which is the projection of u onto v. It's the part of u that goes in the direction of v. And then add that to u sub 2, which is the green part, the part that is orthogonal to that red part. So that u sub 1 vector is going to be the projection of u onto v. It's going to be the part of u that goes in the v direction, right? So to get that, I'm going to use the formula that's on page 444, which is u dot v over the magnitude of v quantity squared, all times vector v, right? And we can do that, again, you don't have to have that formula memorized, that's just straight up, you're just going to do it, right? You're going to look it up in the book and then do it. So u dot v is going to be a 15 plus a negative 4, so it's going to end up being an 11. So I'm going to get that this is an 11, right? On top of the magnitude of v, right? The magnitude of v would be the square root of 5 squared plus 1 squared, so that's a square root of 26, but I'm going to square it, so it's an 11 over 26. Great. Cool. And then times vector v, which was a 5, sorry, it's not a very good 5, which was a 5, 1. Okay? So I'm going to get that this u1, the thing that's red there, is essentially going to be a vector that looks like a 55 over 26, as lovely as that is, 11 over 26. And that's my vector, right? That's the first vector, right? And I'm trying to write vector u as two different vectors, right? Well, the easy way to find the other vector, right, is to notice that what I'm doing here is saying that u1 plus u2 gives me u. So if we, over here, note that what we're saying is vector u is u1 plus u2, right? So if I want to find the u2 vector, I could just subtract u1. So the u vector minus the u1 vector should give me the u2 vector I want. So if I want that green vector, that u2 vector, right, my u2 vector should just be my u vector, which was 3, negative 4, minus my u1 vector, which we just found to be that lovely 55 over 26, 11 over 26. Again, not super fun. You're going to have to get a common denominator of 26. I get that that's not super duper awesome, but you'll survive, right? So 3 times 26, right? 3 times 26 should be a 60 and an 18, so a 78, right? So this is so if we just want to clean this up right here, this is a 78/26. And by the way, this is what happens when you make up numbers in your head when you're doing a problem. Sorry, people, my bad. 4 times 26 should be an 80 and a 24, so it should be a negative 104. So negative 104 over 26. So it looks to me like my u2 is a 78/26 minus a 55/26, which seems to be a 23/26. And a negative 104/26 minus an 11/26, which I think is a negative 115 over 26. So that's my other vector. That's my u sub 2. So what I've been able to do is write that u sub 1, the red vector, would be the part of u that would go in the v direction, and that u sub 2 is the part of u that is perpendicular to that. Now this is relevant for a bunch of stuff when we get to physics, and our next example will actually be a little bit physicsy. But one of the reasons it's relevant is that, for instance, when you're calculating friction sliding down a ramp or something, it's the force that's perpendicular to the surface that's going to determine essentially how your friction functions and how much friction's happening. So, like, for instance, if you are trying to slow down and you're using something where you're applying the brake pressure by pushing downward, right? The bigger the force pushing down essentially is going to determine how much you slow down, right? If you're using one of those old scooters where you push down on the brake to try and brake, right, where you step on the wheel, the harder you push down, like the larger the magnitude of the force that is perpendicular to the surface, the faster that friction is going to slow you down, right? So Anyway, so when we do physics stuff, it actually matters what the magnitude of these u sub 1 and u sub 2 vectors are. And that's why you do this in physics, but not necessarily in my class.